All right, everyone, what is the frequency in hertz of light having a wavelength of 566 nanometers? So the problem gives us one bit of information, that is 566 nanometers is our wavelength. Wavelength is denoted as a lambda, Greek letter lambda. Okay, so we have 566 nanometers for our wavelength. And the problem is asking for frequency. Frequency is denoted as lowercase Greek letter nu, which looks basically like a V. Okay, so we don't know what frequency is. We're solving for that. Now, to solve this problem, we're going to use this equation over here, where C, which C is the speed of light, is equal to wavelength, or lambda, times frequency, or V. So we need for this problem C, which is the speed of light, and the speed of light is 3.00 times 10 to the 8th meters per second. Okay, so we have our two variables, so we can solve for the third. Let's rearrange our equation here to isolate for frequency. So we have wavelength on the right side with frequency. We want to have frequency by itself. So we are going to divide both sides by wavelength. And we're going to do that so that wavelength will cancel out. And then we can rewrite our equation. Let's flip it and put frequency on the left equals the speed of light over wavelength. So now we can input our numbers and solve. So frequency is equal to the speed of light, that is 3.00 times 10 to the 8th, and our units are meters per second, divided by wavelength, which we have as 566 nanometers. Now, the speed of light is in meters per second. So if we use 566 nanometers on the bottom here, our meters and nanometers won't cancel out like we need them to. So we need to convert one unit to the other so that they're the same. So let's take our 566 nanometers and let's convert that to meters. So we're going to multiply by a conversion factor, and we want meters in the end. Okay, so I need to multiply by nanometers by the relationship of meters over nanometers. What is the relationship between nanometers and meters? Well, 1 meter equals 1 billion, or 10 to the 9th nanometers. So let's put 1 meter up top, 10 to the 9th nanometers on the bottom. And then if we do the math here, we're just going to do 566 divided by 10 to the 9th. So we get 5.66 times 10 to the negative 7 meters, and that would be in scientific notation. You could come up with a couple different ways of writing that number. So now let's put that in our equation. So 5.66 times 10 to the negative 7 meters. So now, looking at my units, I have meters on top and meters on bottom. So those are both going to cancel, and we're just going to be left with per second, okay? Or you can also write that as seconds to the negative 1 power, or we actually call that hertz, which is Hz. And that's what the problem wants. So let's do the math here. You are going to put in your calculator 3.00 times 10 to the 8th, everything that's on the top, and we're going to divide by everything that's on the bottom. Now you need to make sure that the bottom stays together here. So let's open parentheses, put 5.66 times 10 to the negative 7, and then close parentheses and hit equals. And looking at your calculator, you should have 5.30035 times 10 to the 14th. Let's round that to 3 significant figures, and we should end up with frequency equaling 5.30 times 10 to the 14th, and our units are again Hertz. If you didn't get times 10 to the 14th, if you got some other power there, make sure that again the bottom of your fraction is all together. Otherwise, your calculator may change your order of operations. Okay, so final answer. What is the frequency in Hertz of light having a wavelength of 566 nanometers? That would be 5.30 times 10 to the 14th Hertz. All right, if you want to see another example, click in the top right. Please like this video if it helped you in any way. Feel free to look in the doobly-doo below for additional help and resources. Please subscribe and ring the bell to get notified for new videos. And thank you so much for watching.